Okay, so let's start the presentation and share the screen. So you should be looking at my slides now. And yes, good morning. As Santos said, I am a research associate in the UK Catalysis Hub, and my full title is Research Associate in Data Management and Software Development. So I'm right in the middle of the topic of this workshop. So thanks for attending. And let's see. So far in this workshop, we have seen two topics, and today we are touching on another two. The first one was Introduction to Data Management, in which we explain some of the needs for data management in general and describe the FAIR data principles. That was really good yesterday because that gives us a context and a reason to work. And we also saw some of the platforms and tools for data management. So all the support that the infrastructures at the recruiter for the Appleton laboratories and also at the different facilities we get for processing and gathering, processing and reducing data. So and also provide some management facilities even for publishing it. And today we are talking about management in practice. So the example that Andy just gave, which is very interesting and touches the main points. So the large quantity, the complexity of the data, and the fragmentation possibly of the data and how it can be stored and shared effectively. And later on, we will hear from other speakers about current and future applications. And there is something that I think Pedro's presentation overlaps a little bit with what Andy was just discussing. So and they have another interesting proposal there. But so these are the 4 parts of the workshop, and now is the turn for the data management at the UK Catalysis Hub. So within the core team, we have 3 lines, or in my particular area, we have 3 lines of research, which is the creation of a data policy for the CAT Hub, which is under review at the moment, the design and development of a catalysis data infrastructure, which is a tool to help us with the management of data, hopefully, and the design and development of the research workbench, which touches on the software for taking advantage of these large quantities of data and maybe having some better ways to exploit this data. We are talking today about the first two, research data policy and data management. So we will be talking about the governance framework for research data and some what data management for us will mean. So creating, working and securing this data. We will also try to convince you of the benefits of this data management approach, show some of the support and how we can take advantage of existing infrastructures, and end up saying that, this data management is now a significant component of the research practice. It's no longer an accessory, but is because of the research we are seeing at Catalysis Hub is one of the main practices that we have to pay attention to. So the research, we start with the research data policy. We have developed this as part of the core team activities from 2019 and to 2020. So currently it's under review. This small link will let you see it, this shortened link. I can put it later on the messaging panel so that everybody can look at it, and it's in review form, so you can comment on it and you can make annotations, and it's open for review until the end of August this year. So, and then the steering group will have that decision on whether or not to make it the official policy for research data at CatHub. So that's the one of the introductory statements. We see that CatHub relies on the production and access to different types of data, and we need to recognize this as valuable research products. Like Andy said, we can take advantage of these products and make more use, like analyzing, getting patterns, and finding better well, application in new ways. We see that the data management is actually like putting the policy in practice. Data management should be oriented towards supporting the policy, making sure that we all fulfill its requirements and aspirations. So, but we would like to point out that the Catalysis Hub does not attempt to have or take over the control of the data produced by partners. Just establish a clear procedure for making those data findable, accessible, interoperable, and reusable. So making it fair, which we saw yesterday, the presentations from our colleagues, that fair is becoming more and more important concept, the fair principles for data publishing. It covers all digital objects produced through UK Catalysis Hub resources. That's the laboratory equipment that the Catalysis Hub provides, the computing resources, software, data assets, funding, and other resources that that the Catalysis Hub makes available for its partner researchers. And research objects can be of all types, like we have seen in the past presentations: raw data, process data, derived data, intermediate data, and end up with the tables and data tables that the researchers produce. So why we need data management is because as projects develop, many things can go wrong. So a laptop can get lost or stolen, a hard drive crash, funding is terminated, team members move on to different projects, and there is and also trusting only your memory to keep track of your data is not a good idea. Fair publishing gives us advantages in this case, because if we take these activities as our new way of working, we can help preventing the accidental loss of data, support the faster recovery when something happens, and we also have the long-term preservation of the data. So these are the what we see as the benefits of fairness. So having data being findable, accessible, interoperable, and reusable. So if it is findable, we can in our practice we keep track of the data assets used. We link to publications. We have evidence for our sponsors. So that's one benefit. If it's accessible, we have rapid retrieval, less worry about securing and maintaining storage devices. For instance, yesterday when we saw the presentations from our colleagues at STFC, Diamond, and the Central Laser Facility, at least for raw data, we are sure that that's stored somewhere in a hard drive, and it will be recoverable So at least that's one point of reference, and we can do the same to all or the other data types that we have. If it's interoperable, it's easier to process and analysis. So it's easier to use it with different processing tools. So although the producers or the creators of different equipment that we use give us software, sometimes the data formats are proprietary and hard to use without the software they provide. So many times the scientist has to translate or migrate the data to a different format. And if that will make would make our data reusable, so this facilitates further future usage, and this means easier for peer review, verification, reproducing or repeating the experiments, and also for applying in new research, like or in future. So this means as this I take it as a something good for a researcher or a research organization, because we all have seen it. I mean, maybe even you as researchers, when you started after your PhD, you had a small manageable amount of data, and it's easy to see, oh, where is the data? That data is in my laptop, or that other data is in that hard drive or that USB stick. But as we progress in our careers, the amount of data and the types of data and the complexity grows consistently. So complying with requirements from funders, from publishers, and from other partners, it becomes increasingly complex. So using effectively the tools at our disposal can alleviate all this. For instance, and the fact that all the data that, or most of the data that we are producing is born digital. So it's not digitized data, is collected in digital form from the different devices, from the laboratory equipment. It is derived from theoretical models and or collected from different specialized database and repositories. So in this diagram at the bottom, you can see the growth, the steady growth of the number of data objects processed for produced by, per year by the catalysis hub. And this is only the ones that we know of. So the ones that have been cited or reported in literature. As you see, the average every year doesn't pass 100 objects yet, but the collected, the collection, the number of data objects that we have to keep an eye on for the catalysis hub is almost, is above 350 now, and maybe more, because we have to update to the latest, to take into account the latest publications. And this doesn't even account for the size of the data objects, because this is just a simple count of one data object, one data set. But the big data sets can contain thousands of objects, and the sizes, as Andy demonstrated, they grow very, very quick. So the being born digital means that the data has strengths and weaknesses for our data sets. So the strengths of this type of data is that it's easy to duplicate, create perfect copies, easy to share. Well, that's if you don't mind the sizes, and convenient for the illustration of results. But the weaknesses are also very important to keep an eye on. And that's why we try to manage with data management, we try to manage these risks. So it's too easy to share. For instance, it's medium dependent, can be corrupted, and that means that we have a loss of data. So all these problems are part of researchers' everyday work. So in the past, the researcher workflow was very clear or well understood. Design the experiment, prepare, perform the experiment, collect data, so on, and ended with the publishing of results. More and more, the expectations of publishers and founders require you also to have a way to say where is the data, because of it's used for validating your results, for making sure that your results are reserved somewhere, and maybe even because we see examples where this data could be further exploited and get more value from the funds that have been put into allowing you to perform your research. So in this new scenario, the researcher also looks a lot like a software engineer, because they have to collect the data, transfer the data between different hardware and software systems, clean and format the data before they can even get to analyzing this data, evaluating models, summarizing, interpreting. So, and keeping all this while keeping track of the data and the metadata associated with it, and at every stage, so that you maybe can follow this chain forward or backward and say this result comes from this part of the data set, and this part of the data set was taken from this instrument this day, and so on. So that those are very a lot of responsibilities to pile up on top of the researcher's normal work. And there is a lot of workflows that different facilities have. So if you see, these are the workflows from Diamond, from the different beamlines at Diamond, from ISIS, and this last one is the one that Alexandra used yesterday somehow to explain the working of the ICAT. So this extended data management workflow at the facilities can be used to keep track, or is effectively one tool that we can rely on, because they track many of the things that are interesting about the experiment. So what was the grant that provided the funding for the experiment, who were the principal investigators, who was the experiment, when was the reading taken, what was the composition of the sample maybe, and the software that was used for reduction and data analysis. So in a sense, we have parallels between the researcher's workflow, here shown at the bottom, and the infrastructures or the facilities workflow, which is here at the top. So we can draw parallels between each of these activities and say, okay, that's been taken care of. We can move on to different things. The only some of the work is a bit minimal, because now we can just say, oh, my data is being published, or my data is available and can be retrieved from this repository. This is the ID number, and that's it. So that's a really great support. And we also have support from research institutions, universities, industry, and publishers, because they also provide these kinds of repositories and catalogs for data, which can be also taken advantage of for storing all results. So we have already a big ecosystem of research data repositories from the facilities ones at the STFC, like eData, the ISIS data catalog, the Diamond Topcat repository, the university repositories, which we all know and have worked with, and also specialized database like the Cambridge crystallographic database or the data based on inner and outer shell excitation spectrum repository. That's an EU resource, or some resources abroad like SUMCAT at Stanford. And moreover, we also have general purpose repositories which can be used as a last resort, and some of our colleagues already are using, like Zenodo, like Figshare or Dryad, which also can host your data. So making effective use of all these repositories, we could get rid of all our USBs and personal hard drives, and take some comfort in knowing that our data is stored properly. So this takes you now to which role can we take in data management with the Catalysis data infrastructure. So we already have a prototype. This is a temporary address. We will change it eventually for a proper URL. You can see it, you can go to it, and you can start making, looking at some of the proposal, part of the proposal that we are doing. So we are proposing to create a catalog that links raw derived data, spectra, and images to Catalysis Hub research. So, and the main point of contact is this link between publications and datasets, and also the authors of these datasets. So we have this is the current form, and again, it's a proposal. If you have ideas, we are really happy to hear your ideas for how to carry further develop this platform. But we want to show or maybe argue for why a catalog and not another repository. First, because we know, as our colleagues have demonstrated, you are really very familiar with different repositories in existence. You already use them. Here is a list of the repositories that you have used, included in the publishers, including in the different databases like CCDC, the ISIS and university research facilities. And we can even make a table of the top publishing researchers, so saying how many data objects are associated to your name through your publications. And that's a main thing to highlight, that at the moment the data assets are like a lesser, broader or lesser product of research, but we want to bring it to the forefront. So we think that there is no need for yet another research data repository, but we need to explicitly bring up these connections between our research and our datasets. And we already have an overview of what this looks like. And we can also use this tool to monitor the fairness of the data. So this is a bit old because it's from December last year, sorry. And those were the numbers we had then. Now we are up to more than almost 9,000 citations for the publications. The number of publications has also grown. We are nearing 400 publications, and the data sets are also increased in the last months, as well as the number of authors per publication. So we have at least 6 or 7 authors per publication. So every publication increases the number of authors that we are that have collaborated with us. And the first thing we can see is the growth in the data. For instance, in the last 2 years, 2019 to 2020, each publication cited on average 3.2 data objects. If all the publications that we had at that time, the 357 had listed publications, we should be listing about 1,100, more than 1,000 data objects instead of the 300 that we are listing. So this is the first sign that there is this iceberg that's been much talked about, the amount of data that's been published and exposed is just a fraction of the actual data that exists or supports these all these research efforts. We can also use this tool to see to ask, okay, what is a fair data set? Is well annotated, is referenced in the publication, is available, is complete, it has raw, intermediate, and processed data, is reusable because it has been licensed and it has been made available already. It doesn't have to be open, as Abigail pointed yesterday, because fair doesn't mean open. Fair means that you can find it, you can access it, you can work with it. But if you have to ask for the license owner or the proprietor, that's the data is still fair because you can eventually get to it. So we could ask this mirror and say, who is the fairest of them all? And I just took one example from the database, and it's this diphosphine ligands, which is a very complete data set that I liked, and June and Emma Gibson are co-creators of this repository. So the article cites available data, process data, models, raw data, and it's all stored in different places. So it has a data availability statement that has identifiers that let you get to the data, both in the crystallographic database and in the university repository. The advantage of the crystallographic database is that it has the proper metadata. It has it can be exported to different formats. It can be viewed in the 3D form. So you already know all these details. And I think it's more than 20 crystals that were published with this publication. And in addition to that, we also have the deposit at the institutional repository from the University of Bristol. And this is a very complete set of data. It has diffraction data. It has different metadata associated to it. It even contains a text file describing the whole data set and all the components. So in this case, this is what we would like to see as the gold standard for how we would like to all data to be published or made accessible, like the fairest data. And this gets you by, not by design, but it's as a byproduct or a happy accident, to reproducible research. So materials are well preserved, so we can it can be used. We have access to the data, the software, and the methodology used to create these data sets. So we can see where all this comes from. That's a big important research precept, the reproducibility. The research is well documented. There is transparency. We can verify the provenance, and we can augment or extend our research. So this there is like this. They said this is a happy accident. So we are not aiming for this, but if we are fair and we are manage our data correctly, we obtain extra benefits. And I wanted to argue that it's not really new. I like this story from Tycho Brahe. He was a Danish researcher who collaborated, it's famous because his data was so good that it helped Kepler advance his proposals for the cosmic model, and it is one of the fundamental references for the work of Newton. So Kepler and Tycho are some of the giants that are often mentioned. So if you are fair, you can also be one of these giants. So the UK Catalysis Hub is aiming to have this high value data published and preserve these key data assets, which are the data sets that we are that are being produced every day, but research. So but I want to conclude saying that data management and fair publishing are beneficious to you as a researcher. It's not, it also benefits the community, but to you, it will give you peace of mind. It will give you, make easier the control of your data, make it more efficient, prevent the adverse effects of data being digital, and it will have definitely a positive impact on your research. So it will be easier for you to fulfill the funders and publishers' expectations. It will extend the life of your research and your research assets, and prevent the repetition and waste of resources in repeating experiments that have already been presented. And that's all I wanted to talk to you about for now. I just would like to thank our colleagues at the UK Catalysis Hub, present and past, because I'm new to all this. I just started when I started here, and I keep on learning a lot from all of you. So thanks to all my colleagues and co-workers at the Catalysis Hub, at the Research Complex, and the Science, Technology and Facilities Council, and especially the Scientific Computing Department. And that's all for us. Thank you very much.